today's topic. Okay, so the question says that just for a minute. Yeah, the question says that here what is the current passing through the resistance R1. So the resistance R1 is this, so I have to pass the current through here. So you can very obviously see that this is the, how can I say that whether it is in forward bias or it is in reverse bias. Okay, I hope that was also clear. Then I gave you the homework, and let us now solve that homework, and then we'll proceed with today's topic. Okay, so the question says that just for a minute. Yeah, the question says that here what is the current passing through the resistance R1. So the resistance R1 is this, so I have to pass the current through here. So you can very obviously see that this is the high potential, so the current will flow like this. If I say that the current flowing is I, so the current flowing is this way, so it will go this way over here, this way over here. Okay, let us say this is I1. Okay, remaining I2 goes here like this. Now this is looking forward bias to me, and this is looking reverse bias to me. So of course reverse bias will be having infinite resistance of reverse bias is infinite, therefore this will break, no current will be flowing through here. So if I redraw the circuit is something like this. The circuit is something like this. Okay, this is my 2 ohm, this is my T2, this is my 2 ohm. Now resistance in forward bias, that is equal to 0, right? Okay, so what will be happen here? This will just turn into a normal wire. Okay, a simple wire. So this is my entire circuit. The resistance is 10 volt. The potential here is 10 volt, and the resistance here, the net resistance is, since you can see that this 2 and this 2 are in parallel, so this will be equal to 2 plus 2, that is equal to 4 ohm. Okay, so the value of the current is V by R, that is equal to 10 by 4, this is equal to 2.5 ampere. Okay, the current that is flowing through here is equal to 2.5 ampere. I hope that is clear. Okay, sounds good. So yeah, these kinds of questions are basically asked. Okay, now I will be giving you more amount of questions that has been asked in the recent examination. Okay, try solving this one. Okay, the question says that in a PN junction diode, okay, in a PN junction diode, the change in temperature due to heating, so it affects the reverse resistance, affects only the reverse resistance. Okay, option number 2, it affects only the forward resistance, affects only forward resistance. Okay, the third one, it does not affect the resistance of PN junction, does not affect the resistance of PN junction. Okay, or option number 4, which says that affects overall the IV characteristics of PN junction, IV characteristics of PN junction. Okay, I think this sort of questions are only understood when they are done in the form of question. So just have a look on this and try to figure it out which is the correct answer here. Okay, so if you read it, so it says that there is a PN junction diode, and when I will change the temperature by heating, what will happen? So will it affect reverse bias resistance? No, resistance if affected, then it will be of both the reverse bias and the forward bias. So neither option A is correct nor option B is correct. What about option 3? Does not affect resistance? No, it will definitely affect, right? Because temperature is something related to mobility. Therefore, yeah, this is the wrong. What we are left with option number 4, and hence option number 4 is correct. And this is also true. It will affect the overall IV characteristics of PN junction, because the slope of the graph that gives me the value of resistance. So if the resistance of the forward bias and the reverse bias both gets changed due to the temperature, so what is happening over here? You will find that since overall these are changed, okay, the slope will change, and since the slope will change, my entire IV characteristic will change. Is that clear, everyone? Okay, good enough. Let us talk about the next question. The next question is, two ideal diodes are connected are connected to a battery as shown in the figure, as shown in the circuit. Okay, the current supplied by the battery, the current supplied by the battery is what? So the circuit looks something like this. Okay, so yeah, this is over here, this is my 5 volt. Okay, this is my D1, this is my D2. The resistance over here is 10 ohm, the resistance over here is 20 ohm. Okay, just think about this and tell what is the correct answer to this. Just think about this and tell the right answer. So the question says that what is the amount of current that has been supplied by the battery? Well, the question is simple if you understand it. This is the higher potential, so the current will be moving here. If the current is moving here, it will go like this and it will go like this. So obvious. Now you can see that this is the condition of reverse bias. This is the condition of reverse bias. So current will be not flowing through here. Okay. What I am left with, the current will go like this and it will just complete the circuit. Therefore I will say that the value of current is equal to V by R. This is equal to 5 by 10, that is equal to 0.5 volt. This is equal to 0.5 ampere. Okay, the current flowing through this is 0.5 ampere. Okay, fine. Let us take this question. The question says that in forward biasing of PN junction, what happens? The positive terminal of the battery is connected to the P side, and the depletion region becomes 6, and the depletion region becomes thick. Okay, the second option is that the positive terminal of the battery is connected to the N side, and the depletion region becomes thin, Okay, the third option says that the positive terminal of the battery is connected to N side, okay, and the depletion region becomes thick. Okay, or the option number 4, okay, you can make a guess that the positive terminal of battery is connected to P side, and the depletion region becomes thin, and the depletion region becomes thin. Okay, now check whether which of these option is correct. Okay, whichever option will be the correct one, just mark it correct. So when you read it, okay, in forward bias, the positive terminal, if I say that this is my forward bias condition, the P side is toward the high potential and N side is toward the lower potential. Okay, so you will find here that the positive terminal is toward the P side. Okay, so this and these both are wrong. What is left? Option number 1 and option number 2. Okay, and it says that the depletion region becomes thick or thin. Okay, well, answer is option number 4, because the depletion region becomes thin. Okay, but if in examination you just got confused that whether it will become thick or it will become thin, so there is an easy way to get with this. What you can do is remember that depletion region, as the name suggests, depletion region is the one which is decreasing it. So depletion region is formed in between. Okay, if depletion region is thick, more amount of electric field is created. Okay, in forward bias the electric field is like this. Okay, and the intrinsic electric field produces this way. So if more amount of resistance is provided here, if it is thick, more electric field will be induced, and that will decrease the electric field created by the battery, which is not good for us, because I want the conductivity to be greater in forward bias. So it should be thin enough. So that my semiconductor can function optimally. Okay, is that clear everyone? Okay, this is one way of how you can just help yourself to revise and recollect if you got confused. Okay, I hope that was good. Okay, the next question, the question says that the current in the circuit will be, the current in the circuit will be, which circuit? So the circuit looks something like this. Okay, so yeah, this is the circuit over here. Okay, and yeah, so here you have to find that if this is my 20 ohm, okay, this is my 5 volt, this is my D2, okay, this is my 30 ohm, this is my D1, and this is my 20 ohm. Okay, you have to tell that what is the current in the circuit. I think this is a good question. Okay, simple. Just check whether which of the following is in forward bias or reverse bias. So the current produced by the battery will be this way, it will go this way and this way. Now when it will reach to this one, it will see that here this is reverse bias condition, so no current will be flowing through here. The current will go and it will come like this, as simple as that. So you can see from here that I am having simply a diode, okay, a resistor, okay, a resistor again, and a battery. The important thing here is that in forward bias the diode is just like a naked wire. So this is 30, this is 20. Okay, my net resistance, since both of these are in series, so 30 plus 20, that is equal to 50 ohm. What is the voltage? So voltage is given as 5 volt, so I'll be writing the value of the current is V by R. This is equal to 5 by 50, this is equal to 0.1 ampere. Okay, the amount of the current flowing through this is 0.1 ampere. As simple as that. Got it, guys? Okay, I hope you understood this. Fine. What about the next one? So the next question is something like this. The question says that the application, okay, this is the question that you should know. That application, what is the application of forward bias? What is the application of forward bias to a PN junction? To a PN junction. Okay. Option number A, widens the depletion zone. Widens the depletion zone. Okay. Option number B, increases the potential difference. Increases the potential difference across the depletion zone. Okay. Option number 3, okay, increases the number of donor. Increases the number of donor on the n side. Okay. Or option number D, okay, decreases the electric field. Decreases the electric field in the depletion zone. Okay, have a look which of the following option could be the right one. Okay, if I look to it carefully, the application of forward bias to PN junction. Okay, so it widens the depletion zone. In forward bias it gets thicker, not widened. Option number 1 is wrong. Okay, increases the potential difference across the depletion zone. No. Okay, potential difference is decreased, okay, due to which electric field is decreased and overall my semiconductor is functioning properly. It increases the number of donor on the n side. No. Okay, it cannot create any impact on the donor ion or on the acceptor ion. It can allow recombination, okay, doping and all, they can allow recombination, they can allow generation, but they cannot interfere with the donor. Okay, so this is wrong again. I am left with option number 4 and well, that is the right answer. As I have just mentioned that in forward bias condition, the depletion region should be thin enough so that small amount of electric field is produced, and this small amount of electric field offers less resistance to the will cause less decrease in the actual electric field. Okay, well, let us take the next one. The question says that the reverse bias applied to a PN junction diode. Applied to a PN junction diode. So what is the characteristics of this? First, lowers the potential barrier. Okay. The second one, rises the potential barrier. Okay. Option number C, increases the majority current carrier. Increases the majority carrier current. Okay. Or option number D, increases the minority carrier current. Okay, so yeah, in reverse bias condition, what happened? It lowers the potential barrier. No, the potential barrier is increased. Option number B is the right one. Let us take the next one. Increases the majority charge. Increases the majority carrier charge. No. Increases the minority carrier charge. Not at all. Okay. The correct answer is option number B. I hope that is clear. Okay. Let's go to the next one, and this is the last question for now. Okay, after this I will be taking some of the theory. Okay, the question says that the diode used in the circuit shown in the figure has a constant voltage drop at 5 volt at all current and a maximum power rating okay, of 100 milliwatts. Okay, question says that what should be the resistance, what should be the value of the resistor R connected in series with the diode for maximum current. Okay, this is a question of logic. Okay, just have a look on this question. Question says that this is a resistance R whose value is unknown to me. Okay, it is connected to a diode as shown here, and this is connected to a battery. The battery is 1.5 volt as mentioned. Okay, I'm sorry, just a minute. Okay, yeah, so this is given to me. Okay, the potential difference, okay, the voltage drop across this is given as 0.5 volt. The voltage drop across the diode is 0.5 volt. Okay, you have to find that what is the resistance here, so that maximum amount of current can flow through this. Okay, well, you need to get it very clearly, that understand it very clearly. Okay, question says, okay, what is given here, that 1.5 volt is placed here. Okay, out of this and so this is not 5.0, this is 0.5. Okay, now this 1.5 volt battery is present here, and here it is not given an ideal diode. This is a real diode. Okay, this is a real diode, and in real diode there will be some amount of resistance that will cause the potential drop. So here the potential drop is 1.5. Now if 1.5 is supplied, out of this 0.5 is dropped here, what is dropped in the resistor? So across the resistor 1 volt is dropped. So what I find from here, that the value of the current through the resistor, this is equal to V by R. Now what is the value of this? So V is equal to 1 by 1. Okay, sorry, 1 by R. Okay, now I can say that R is equal to 1 by I. Now I have to find the value of the I. How can I find the value of the I? Well, I know from here that the current passing through the diode is equal to the current passing through the resistor as well, since these are in series. Okay, and I can make a discussion that the voltage across the diode, this is equal to 0.5. Okay, and the power that has been obtained here, you can see that the power rating is 100 millivolt. So I can write that P is equal to VI, therefore I can say I is equal to V by P. Okay, sorry, P by V, this is equal to 100 milli, that is 100 into 10 to the power minus 3 divided by 0.5. Okay, this will give me 0.1 by 0.5. Okay, this is equal to 1 by 5, that is equal to 2. So yeah, what is the value from here? Have I written correctly? So I think this is equal to I think this will give you a value of 1 by 2, right? Okay, so what is the value of the current from here? The value of the current that I get from here is equal to 1 by 2. Okay, you can simply say that this is not 1 by 2, this is actually 1 by 5. Okay, yeah, you can say it is equal to 1 by 50 ampere. So what is the value of the current that I get from here? The value of the current is equal to 1 by 5 only. Okay, let me make it very clear because I am also getting confused. I can write 100 into 10 to the power minus 3 plus 2 by 0.5. This is equal to 0.1 by 0.5, again 1 by 2, sorry 1 by 5. So the value of the current here is 1 by 5. Therefore I can say that since the current is same, I can write that the value of the current through the resistor, sorry, the resistance is equal to V by R, V by I, which is equal to 1 by I. What is the I here? I is 1 by 5. Therefore I get 5 ohm. The net resistance here, okay, the resistance of the resistor is equal to 5 ohm. If it is 5 ohm, then you can see that the condition is fulfilled. Okay, but this is not actually the main thing I wanted to know from the question. What you if you just read it carefully, question says it has a constant voltage drop of 0.5 at all the current and maximum power rating of 100 millivolt. Okay, do you remember the IV characteristics of the graph? The graph in the reverse bias is like this, and in forward bias, the graph was something like this. The graph was something like this. Okay, at a single voltage, okay, there was a point, there was a voltage. At this voltage, you will find that the current keeps on increasing. The current keeps on increasing, but repeating it again, okay, the current keeps on increasing, the voltage is same, therefore it was said that the resistance here is variable. Remember, okay, my voltage is same, okay, but my current keeps on increasing and increasing, therefore I can say that the resistance of the diode becomes variable. Okay, therefore at this point the voltage will remain the same, the current will keep on increasing because the resistance of the diode is adjusted itself. Okay, therefore it is said that here the potential difference will be 0.5, and in that case you will have all the sort of current that is possible. You will have all the sort of values of current that is possible, and due to this multiple current that is possible, I will have a condition of power, increasing power, and the maximum power will be also obtained over this. Okay, so I hope you are getting this. What is the significance of this graph? Understood, man? Okay, if you have not understood it, guys, I am repeating this again for you, that in the IV characteristics of the graph is looking something like this. Okay, in this case I can finally observe that at a single voltage, let us say that the voltage is 5 volt. Let us just assume that the voltage is 5 volt. At that very 5 volt you are having multiple value of current. That means current is variable, okay, voltage is still the same. Okay, therefore V is equal to IR. If this is same, voltage is increasing, therefore resistance has to keep on decreasing. Basically
it's lack of personal attention. With one-to-one mentoring, every doubt is addressed, every concept is applied, and real improvement begins.